The Millennium Tower is the tallest residential building in San Francisco, with 58 stories above the ground and 419 luxury condominium units. The tower opened to residents in 2009, but even before construction was finished, engineers could tell that the building was slowly sinking into the ground and tilting to one side. How do engineers predict how soils will behave under extreme loading conditions? And what do you do when a skyscraper's foundation doesn't perform the way it was designed? Let's find out. I'm Grady, and this is Practical Engineering. In today's episode, we're talking about the Millennium Tower in San Francisco. Skyscrapers are heavy. That might seem self-evident, but it can't be overstated in a story like this. An average single-story residential home is designed to apply a pressure to the subsurface of maybe 100 pounds per square foot of building footprint. That's about 5 kilopascals, the pressure at the bottom of a knee-deep pool of water. With its concrete skeleton, the Millennium Tower was designed to impose a load of 11,000 pounds per square foot, or 530 kilopascals to its foundation, about 100 times more than an average house. It would be impossible for just the ground surface to bear that much weight, especially in this case, where the ground surface is a weak layer of mud and rubble placed during the city's infancy to reclaim land from the bay. That tremendous pressure is why most tall buildings use deep foundation systems. The Millennium Tower's foundation consists of a 10-foot or 3-meter thick concrete slab supported by 950 concrete friction piles driven into the subsurface to a depth of about 80 feet or 24 meters. Friction piles spread out the load of the building vertically, allowing much more of the underlying soils to be used to support the structure without becoming overwhelmed. The piles also allow the foundation to bear on stronger soils than those at the surface. Driving the piles so deep allowed the building to not sit on the surface layer of artificial fill or even the soft underlying layer of mud, but rather on the dense, sandy soil of the Colma Formation below. This is a fairly common design in San Francisco, with more than a dozen tall buildings in the downtown area utilizing a similar foundation system, including some nearly as large as this one. However, it's not the dense sands causing problems for the Millennium Tower, but what's underneath. Below the Colma Formation is a thick layer of Ice Age mud, locally known as the Old Bay Clay. Thanks to the geologist for that name. When the building was designed, the project geotechnical engineers predicted that it would settle 4 to 6 inches, or 10 to 15 centimeters, over the structure's entire lifetime, mainly from this layer of Old Bay Clay below the bottom of the piles. But even before construction was complete, the building had already settled more than that. I have a video that goes into greater detail about soil settlement that you can check out after this, but let me summarize the high points here. The ground below your feet may seem firm and stable, but when subjected to increased loading, and especially when that loading is extreme like that of a concrete skyscraper, soil can compress in a process called consolidation. Essentially, the soil is like a sponge filled with water. An increased load will slowly squeeze the water out, allowing the grains to compress into the empty space. Settlement is usually a gradual process because it takes time for the water to find a path out from the soil matrix. But some things can accelerate the process, even if they're not intentional. The Millennium Tower was already designed to put more stress on the underlying Old Bay Clay than any other building in the area. However, construction of the tower's basement also required the contractor to pump water out of the subsurface to keep the site dry. This is often done using vertical wells similar to the ones used for drinking water, but usually not as deep. This deliberate and continuous dewatering of foundation soils accelerated the settlement. Then other construction projects nearby began, including the adjacent Transbay Transit Center, which required their own deep excavations and groundwater drawdowns. All these factors added up to a lot more settlement than was initially anticipated by the project's geotechnical engineers. The result was that by 2016, when the public first learned about the issue, the building had already sunk more than 16 inches or 41 centimeters, triple the movement that was anticipated for its entire lifetime. Unfortunately, that settlement wasn't happening evenly. Instead, the northwest corner had sunk a little lower than the rest of the foundation, causing the tower to tilt several inches in that direction. The media had a field day reporting on the Leaning Tower of San Francisco, and accusations started flying about who was to blame and whether the city had covered up details about the building's movement. The developer continued insisting that the building was safe, reiterating that all buildings settle over time and the Millennium Tower was no different. But it definitely was different, at least in magnitude. With so much attention to the building, the city commissioned a panel of experts in 2017 to assess its safety, both for everyday use and in the event of a strong earthquake. By that time, the building had settled another inch and was out of plumb by more than a foot or 30 centimeters. That's not something you could notice by eye and was probably only discernible to the most perceptive residents, but it's well beyond the 6 inches allowed by the building code. Even so, the panel found that the building was completely safe, and the settlement had not compromised its ability to withstand strong earthquakes. However, they cautioned that the movement hadn't stopped and further tilting may affect the building's safety. At the same time, and despite engineering assessments confirming the building's safety, the condominium prices were plummeting. No one wanted to live in a building that was sinking into the ground with no sign of slowing down. It didn't take long for lawsuits to be filed. By the end of it, just about every person and organization related in any way to the Millennium Tower was involved in at least one lawsuit, including individual residents, the Homeowners Association, the building developer, the Trans-Bay Joint Powers Authority, and many others. In total, there were 9 separate lawsuits involving around 400 individual parties. After many years of complex litigation, a comprehensive settlement, of the legal kind, was eventually reached through private mediation. The result was that no one took the blame for the building's excessive movement, condo owners would be compensated for the loss of property values, and most importantly, the building would be fixed. During mediation, the retrofits to the building's foundation to slow the sinking and de-tilt the tower were a big point of contention. One early plan was to install hundreds of micropiles, small diameter drilled piles, through the existing foundation down to bedrock. But the estimated cost for the repair was as much as $500 million, more than the original cost of the entire building. Turns out it's a lot easier to drill foundation piles before the building's built than afterwards. The challenges associated with working below the building, like access, vibrations, noise, and lack of space, drove up the price, and the parties couldn't agree to pay such a substantial cost. An unconventional alternative proposed by the developer's engineer ended up resolving the dispute, and as of this writing is currently under construction. The proposed fix to the Millennium Tower is to install piles along 2 sides of the building's perimeter. That may seem kinda simple, but there's a lot of clever engineering involved to make it work. 52 piles will be drilled along the north and west sides of the tower all the way down to bedrock. Unlike the original plan, these piles will be installed outside the building below the adjacent sidewalks, saving a significant amount on the construction cost. An extension to the building's existing concrete slab will be installed around each pile, but not rigidly attached to them. Instead, each pile will be sleeved through and extended above the concrete slab so that the building can move independently. The slab will be equipped with steel beams centered above each pile and anchored deep within the concrete. Finally, hydraulic jacks will be installed between each of the 52 piles and beams. Once everything is installed, the contractor will use the hydraulic jacks to lift the building's foundation, transferring about 20% of the load onto the new perimeter piles. That means each one will be carrying around 800,000 pounds or 360,000 kilograms. The goal of the upgrade is to remove weight from the clay soils below the building, transferring it to the stronger bedrock further below and thus slowing down the settlement. The design requires that the holes be over-drilled so that no part of the new piles can come into contact with the old bay clay and put any weight on this weak subsurface layer. The annular space between each pile and the clay will be filled with low-strength material only after the hydraulic jacking operation is complete. Once the building is safely supported, each pile will be enclosed in a concrete vault below the ground, everything will be backfilled, and the sidewalks will be replaced. If all goes according to plan, the settlement on the north and west sides of the building will be completely arrested. With less load on the original foundation, the sinking of the other 2 sides will gradually slow to a stop, straightening the building back to its original plumbness, but just a couple of feet lower than where it started. Of course, expensive and innovative construction projects rarely do go according to plan, and this one's no different. The city of San Francisco and the design engineers were carefully monitoring the building's movement as construction of the retrofit got started in May 2021. It didn't take long to notice an issue. The vibrations and disturbance of drilling through the Old Bay clay were making the settlement accelerate. The speed at which the building was tilting and sinking started to increase as the drilling continued. In August 2021, construction was halted to reassess the plan and find a solution to install the foundation retrofit safely. As of this writing, crews are testing some revised drilling procedures that they hope will reduce the disturbance to the clay layer so they can get those piers installed and the building supported as quickly as possible. The story of the Millennium Tower is a fascinating case study in geotechnical engineering. Our ability to predict how soils will behave under new and extreme conditions isn't perfect, especially when those soils are far below the surface, where we can only guess their properties and extents based on a few borehole samples. In addition, buildings don't get built in a vacuum, and the tallest ones are usually at the center of dense urban areas. Soils don't care about property lines, and you can end up with big problems by underestimating the impacts that adjacent properties can create. Most people will wonder why the building's foundation didn't just go to bedrock in the original design. The answer is the same reason my house doesn't have piles to bedrock. No one likes to pay for things they don't think are necessary. If those geotechnical and structural engineers could go back in time, I think they probably would go with a different foundation. But whether they could have reasonably predicted the performance of the original design with all the extra dewatering and adjacent construction is a more complicated question. The Millennium Tower is also an interesting case study in the relationship between engineers and the media. The developers, engineers, and the city have shown that the building is perfectly safe through detailed modeling and investigation. And yet, the prices of those luxury condominiums plummeted with the frenzy of reporting about the settlement and tilting. Those prices depend not only on buyers' confidence in the building's safety, but also their willingness to be associated with a building that is regularly in the news. The value in the multi-million-dollar repair project will be not just to slow down the settlement, but also to slow down the articles, news segments, memes, and tourists from remembering this building as the Leaning Tower of San Francisco. I know I say this at the end of all my videos, but this is not the whole story. I did my best to summarize the high points, but there are many more details to this saga. I definitely encourage you to seek out those details before drawing any hard conclusions. It's an excellent example of the challenges and complexity involved in large-scale engineering projects, the limitations and uncertainty in engineering practice, and the interconnectedness of regulations, engineering, and the media. I'll be keeping an eye on the progress of the foundation retrofit. Thank you for watching, and let me know what you think.